Okay, in the last video we saw data frame object, and we saw actually how to add and remove columns, how to process data, how to index, how to actually mask, or how to apply conditions and selections in pandas. We saw that very briefly, but in this particular video we are going to see one kind of missing value, sometimes called nan, or not a number, or maybe not anything, or sometimes this none type, none, which is the default return type of any function in Python. This none type is also sometimes in pandas is treated as nan, or nan is treated as none, or interchangeably anything. Let me give you what do we mean by that. Let's say we have two dictionaries. Let's say one dictionary is A with key value A, and the value is 1, then B and the value is 2. Okay, the other dictionary is B and C. So for example, that is one record with columns A and B. So A and B are the columns. On the first record, the value of A is 1 and the value of B is 2. Now let's say we want to insert another record in the same data frame. Now the value of B is available in the second time. The value of B is available, which is 3. And the value of C is available, which means a C column is added now. But for the value C, the first row value is not available, so we will say this value is missing here, but in the second row we have 4. Similarly, the value of A is missing for the second row, and that is a missing value, which is sometimes called nan. So these are missing values, and they are typical when you are working with data and you're reading data and you're getting data from somewhere, or large files and stuff like so. So pandas give some methods to handle these kind of this kind of situation. Let's say A equals pd dot data frame, again a dictionary. Let's say we have A 1 and B, let's say 4. That's the first row or record. The second record, let's say, is another dictionary. Let's say B is -3 and C is, let's say, 9. Let's say that's our data frame A. So now if you print this A, if you see the data inside A, you will see, what's the problem? A is this, and B, have we applied something in a wrong way? Let's see. Yeah. Oh, we have to create a list. That's the, okay, we have to create a list of it. You have to create a list of dictionaries. That's the proper way of calling it. So we missed just the syntax, list of that. Okay, right. So now we have this A, we just call that A, and this value is missing and that value is missing. And in large data files, this is typical. I mean, there are a lot of values that can be missing. One way that pandas applies to handle these missing values is to just fill these missing values with some fixed number. For example, there is a fill na function, and let's say you supply 0. That means wherever there is a not available or not a number value, fill that with 0, or maybe any value you want to fill that with. So that is one way to do that. And now if you see, the value of A is all the non-values are filled with that. Another kind of function that is available in pandas that is sometimes used, that is drop na. That function drop na. What that does is it drops all the records that contain a missing value. Sometimes if that is feasible, I mean dropping all the records that contain missing values, if that is feasible, then go for that. But if the missing values are a lot and they are spread over a lot of rows, then dropping all those kind of records, they will create a lot of data loss, and and then it become really really important how to handle these missing values. However, you can fill the missing values using fixed value, or you can drop them. And later on we will see in scikit-learn that there are other ways of handling the missing values as well. You can fill each column missing values in each column using an average, or using, for example, a regression. There are ways to handle these missing values. But in pandas, these two functions are right away there. You can fill all them with a fixed value, for example, or you can drop them and you are ready to go. Okay, great. Next, we are going to see, as I mentioned earlier, what is a confusion between, what if there is a confusion between implicit and explicit indices, and that I will discuss in the next video. Basically, just to give you a look and feel, what if the explicit indices you supply, they are 1, 3, and 5, and what if you call this particular command 1:3? Will it call the implicit index or the explicit index? That's a problem. So we will see, because 1:3, 1 and 3, they are also explicit indices, and whether this 1:3 is referring to the implicit indices that are default indices, or they are referring to these indices. So this confusion is there, and we will see how to handle that confusion using this lock LOC function and index lock ILOC function. We will see that in the next video. Hope to see you in the next video. Okay, in the previous video I mentioned a confusion that can be there if you have supplied the explicit indices that can conflict with implicit indices. In particular, for example, if this is the series object, or maybe a data frame object if you want to, if for indices, let's just think about the series object. It has these values A, B, C with index 1, 3, and 5. If we, for example, access a particular element, let's say data, with index 1, that means the explicit index for sure. But if, for example, we slice the values, for example 1:3, the default behavior of slicing, if you give the numeric indices, that is to use implicit indices. And by implicit indices we mean that what is at index 1? At index 1, this is B. So B will be printed, for example, or B will be fetched. And then you move to 2, which is C, then C will be fetched. And these are the values that will be printed. But the behavior might be different. You might be expecting to use explicit indices, which means access 1:3, and when the explicit indices are used, the last index is also included. And in that case, you might be expecting the index 1 is of A, so A should be printed, and index 3 is of B, and B should be printed. And this confusion might be there if this is there. So to handle that, there are two functions. One is called LOC, and another method is called ILOC. Whenever you call LOC, that means you are using explicit indices. I mean, you're forcing to use explicit index. And whenever you call ILOC, that means you're accessing elements using the implicit index whatsoever. So let's practice this and see the confusion. See the detail of this kind of confusions in here, Jupyter Notebook. So let's say we have a series object. Let's say A equals PD dot series. And let's say it has values as A, B, and C. That's the value. These are the values, and index as, let's say, 1, 3, and 5. Let's say these are the indices. Let's say this is A. Okay, let's say we access A using 1. That means the explicit index, and that is this. Let's say we access using a slicing operator. Now this will use implicit indices, and it will access it will access these B and C, because 1:3 using indices, implicit indices results that. And we might be expecting that use this kind of stuff. So if we are really interested in using explicit indices, what should we do is we should call the lock function, a lock, and then 1:3. That means use explicit indices. That is to remove the confusions. Now it will use the explicit index 1 and 3. And if, for example, we are interested in using implicit indices, then it is good to use iloc function. Yeah. Now 1:3 is to use implicit indices, and the implicit indices are like these. So and like in series objects, you can do the same in data frame objects. Once you are using loc and iloc, then the further indexing inside these square brackets is exactly the same like NumPy. So whether you use loc or iloc, the indexing mechanism is exactly the slicing mechanism is exactly the same like you have used in NumPy. I mean, all indexing that stays the same. Loc means you're using explicit index. Iloc means you're using explicit implicit index. Let's say, for example, we have our data frame, I guess D. That's our data frame available to us. Let's say I want to access d.iloc. Let's say I want to access the second row completely. The second record, the record that is indexed at, index at 2, which is the third row completely. Let's say I want to access that. Now this 2 is acting as, for example, if you see the second row or the row at the second index, which is the third row, that is completely this, and it returns that. Once you have used iloc, for example, and mostly people use iloc, sometimes loc is also required, but iloc is just to explicitly mentioning that I'm going to use the implicit indexing scheme. Again, you can consider whole that thing as a matrix, and once you have applied this iloc, then you're free to play with the indices like you play with two-dimensional arrays. For example, I want to, I want to reverse, for example, all the rows, and I want to reverse all the structure, for example. Let's say I want to do that, and you can see everything is reversed. I mean, all the indexing, like NumPy, all the indexing is there in pandas. I mean, once you have used iloc, inside is just remember the NumPy indexing and everything like so. Okay, so that's the loc and iloc function. In the next video, we are actually going to just practice the pandas to actually work on a data file that is saved as a CSV file. So we will show you how to actually manipulate, read, and write the data and play with the data, the real data that is there in some CSV file, and how pandas will help you to manipulate the data very efficiently and very quickly. So hope to see you in the next video.